An improved automatic keyword extraction using graph-based modeling. Automatic extraction of key terms from a document is indispensable in the digital era to sum up the documents. For instance, instead of reviewing the full document from beginning to end, some of the author's keywords somewhat explain the discussions of the documents. However, the author's keywords are not adequate to recognize the whole idea of the document. Hence the necessity of automatic term extraction methods is essential. The automatic extraction approaches is mostly classified on some techniques such as natural language processing, statistical approaches, graph-based approaches, natural-inspired algorithmic approaches, etc. Even though there are abundant approaches accessible, the exact automatic keyword extraction is a most important dare in areas, which reveals around documents. In this paper, a study of keyword extraction among graph-based approach is done. In the graph-based approach, the documents are robotically formed as graphs by applying centrality measures during the keyword extraction process. The results of centrality measures were compared and analyzed. Keywords, graph-based methods, keyword extraction, centrality measures. Introduction. Keywords are the least units that can sum up the idea of a document and are frequently used to identify the most appropriate information in a text. To retrieve documents while web hunting or to sum up the documents for cataloging and for such purposes keywords are used. Keywords in a document present essential information about the content of the document. They can assist the users seek through information more efficiently or decide whether to read a document or not to read the document. They can also be utilized for a range of language processing duties such as text classification and information recovery. Handing over the keywords physically is unfeasible because, over the past 1 decade, an enormous growth of computer technology has offered more reasonable and high configuration systems. The bursty data is mounting every day, so we have to preserve and examine the data for efficient use or processing. Data can be available in the form of picture, spatial form, manuscript. Mostly manuscript data is represented in loads of ways like text, graphs, predicates, etc. Keyword extraction play a huge turn in text mining process since, in the broadsheet, social media are used for posting and messaging and all the information of company contained in the form of text. Automatic keyword extraction is the method of opting terms and phrases from the text document that can finally portray the idea of the document exclusive of any human interference. The objective of automatic keyword extraction is the control and pace of present calculation abilities to crack the troubles in access and healing, and the evils related to information organization without involving human connections. To classify the enduring expansion of vibrant formless documents is the major challenge, and managing such unorganized documents causes pricier. The clustering of such active documents helps us to decrease the price. Document clustering by analyzing the keywords of the documents is one of the best methods to organize the unstructured dynamic documents. 2. Literature review. Florian Boudin et al. 1. In this section, the author assess the past workings on keyword extraction methods and declare how unique these methods are discussed. Florian Boudin presented the centrality measures, comparison for extraction of keywords in graph-based approaches. The closeness centrality obtains the optimum results on short documents. Rada Mihalsa et al. 2. The author proposed an innovative unsupervised method for automatic sentence extraction using graph-based ranking algorithms and evaluate the method in the context of a text summarization task, and show that the results obtained compare favorably with previously published results on established benchmarks. R. Nagarajan et al. 3. The authors have projected the new graph-based keyword extraction algorithm, the terms as vertices, the relationship between the terms as arcs, and the projected algorithm which gives more accurate result. Sonawane et al. 4 presented a centrality measure and compare the 5 centrality measures: degree centrality, between a centrality, closeness centrality, eigenvector centrality, and text rank. The authors deal with the document BAU, and finally, the authors say the graph-based text representation is the best way and the result is better than the traditional model. Fratkiskos et al. 5 introduced a novel graph-based approach for text categorization. Contrary to the traditional bag of words model for document representation, the author consider a model in which each document is represented by a graph that encodes relationships between the different terms. The importance of a term to a document is indicated using graph-theoretic node centrality criteria. Marina Litvak et al. 6 introduced and compare between two novel approaches, supervised and unsupervised, for identifying the keywords to be used in extractive summarization of text documents, which enhances the traditional vector space model by taking into account some structural document features. Alwin Mu et al. 7 suggested that MCL graph clustering algorithm, Markov cluster algorithm, can simplify information processing by identifying the characteristics of each vertex in the graph so that it will establish cluster vertices with a specific label. Further, the process of expanding and inflating matrix will be the main process in the clustering of digital news that has been transformed into a graph database. Models that expand aims to show a new edge and remove the old edge in common not needed in the graph. F. Sebastiani et al. 8 The automated categorization, or classification, of texts into predefined categories has witnessed a booming interest in the last 10 years, due to the increased availability of documents in digital form and the ensuing need to organize them. In the research community, the dominant approach to this problem is based on machine learning techniques. A general inductive process automatically builds a classifier by learning, from a set of pre-classified documents, the characteristics of the categories. Adrian Bogoin et al. 9 The author states community the dominant approach to this problem is based on machine learning techniques. A general inductive process automatically builds a classifier by learning, from a set of pre-classified documents, the characteristics of the categories. The advantages of this approach over the knowledge engineering approach, consisting in the manual definition of a classifier by domain experts, are a very good effectiveness, considerable savings in terms of expert labor power, and straightforward portability to different domains. Florian Boudin et al. 10 The author has dealt with key term extraction, which to identify the main topics of the documents by topic rank, candidates key phrases which are clustered into topics, and the topic rank significantly outperforms the state-of-art methods in graph analysis. Shivamoli Lahira et al. 11 The author discussed problems for keyword and key phrase extraction in NLP by applying the PageRank algorithm. The authors have presented a survey for text summarization techniques, which deals with the necessity of text summarization. We review the various processes of text summarization and express the viability and deficiencies of the different techniques. Mehdi Alayuri et al. 12 In recent years, there has been an explosion in the amount of text data from a variety of sources. This volume of text is an invaluable source of information and knowledge which needs to be effectively summarized to be useful. In this review, the main approaches to automatic text summarization are described. We review the different processes for summarization and describe the effectiveness and shortcomings of the different methods. Paulo Tonlia et al. 13 Reverse engineering techniques have the potential to support website understanding, by providing views that show the organization of a site and its navigational structure. However, representing each web page as a node in the diagrams that are recovered from the source code of a website leads often to huge and unreadable graphs. Moreover, since the level of connectivity is typically high, the edges in such graphs make the overall result still less usable. C.Abi Chahine et al. 14 author proposes an innovative method for an indexing support system. This system takes as input an ontology and a plain text document and provides as output contextualized keywords of the document. The method has been evaluated by exploiting Wikipedia's category links as a termino-ontological resources. Santosh Kumar et al. 15 introduced an investigation for extracting the key term without human intervention in text summarization. Talk about the various tactics used for key term extraction and text summarization. Keyword extraction methods. Keyword extraction methods, mainly, are classified into supervised and unsupervised approaches. In the supervised approach, training dataset is essential. In the unsupervised approach, the approach doesn't need training data. In this paper, graph-based methods, unsupervised methods, of keyword extraction have been analyzed. B. Simple statistics. These approaches are easy and don't need training information. The keyword statistics can be utilized to formulate the key terms n-gram measurements, word recurrence, TFIDF, word CO event are some of the examples. C. Linguistics. This approach utilizes the dialectal properties of the words, sentences, and documents. A portion of the etymology includes the syntactic, lexical, etc. For NLP issues this technique can be applied. D. Machine learning. This approach is based upon the processed information to extract the keyword. It needs manual explanations for the learning dataset, which is extremely tedious and mismatched. The SVM, support vector machine, and the naive Bayes are some of the examples. E. Graph-based. These approaches are easy mathematical models, which allow the study of the associations and make the structural information significant. The graph is a discrete data structure consisting of nodes and edges equals V, E. Vertices, also referred to as node, and edges are the lines or arcs, which connect the nodes in the graph. The document is modeled as graph. The terms, words, are denoted by vertices, nodes, and their association is denoted as edges, link. In the graph-based method, the graph describes the significance of the document visually. At the start, the document is transformed into graph, and the keywords of the document are established. Graph nodes symbolize only important words of the documents. F. Other approaches. These approaches are integrated approaches of standard approaches such as statistical approaches, linguistics approaches, machine learning approaches, and graph-based approaches. Fig. 1. Different keyword extraction methods. 3. Methodology. This section focuses concentration on the various accessible keyword extraction approaches found in the graph-based methods. A graph-based method. Usually, graphs are mathematical model, generally graphs as represented as G equals VE. V vertices. E edges. In graph-based keyword extraction methods, the important terms are denoted as vertices, the association among the vertices are connected, the connections are denoted as edges. Centrality measures are mostly used to locate the key terms from the graph in the graph-based keyword extraction methods. Degree centrality. The degree centrality, it takes into description the number of the adjoined nodes. If the network is directed, two types of the measures, in degree, calculates the number of innermost links or the number of predecessor nodes, out degree, computes the number of leaving links or the number of successor nodes. As per degree centrality concerns, a node is important if it has many adjoined nodes. Closeness centrality. This centrality depicts as the equivalent of the cumulative of separations of all nodes to certain nodes, i.e., contrary of farness. The closeness centrality of the node 6 is given in the following equation. In a linked graph, the closeness centrality of a node is a calculated centrality in a graph, which is calculated as the sum of the space of the shortest paths between the node and all other nodes in the graph. Thus, the more vital a node is, the nearer it is to all other nodes. A graph construction. At this phase, the undirected word graph is built for all documents in a corpus, in which the documents are denoted as graph. In each document, the terms are indicated as nodes, and the repetitive associations, among the words of the documents, are referred as the edges. By using syntactic filters, the vertices of graph are filtered, the repetitive count of the words determines the arcs. By using the above said strategy, the extracted terms, from the table 2, were in use to build the graphs, which best reveal the document's formation. During the graph creation, the association between the nodes is drawn as the edges based on their position in the document. For instance, the subsequent graph 1 denotes document ID 1. From the subsequent graph, it is observed that the node's image, processing, science and signals form a separate connected component of the graph and the nodes, mathematics and operation form a separate connected component of the graph. This shows the document ID 1, which deals with two slightly different concepts. The following graph 2, represents the graph form of document ID 2. From the above graph, it is observed that the node's image, processing, and series form a part connected component of a graph, and the node's videos, photograph, and frame form a separate connected component of the graph. This shows the document ID2, which portray the two different concepts, indirectly related. Likewise, the remaining documents have been processed. Similarly, all the 14 documents were converted into graphs. B. Word determination. When the word graph is built, the important word determination pace is pursued, for which definite centrality estimates are useful to dole out the location of every node in a graph. In graph hypothesis, centrality measures elude the markers which identify the most important vertices inside a graph, and that approach is utilized for the errand of positioning the nodes. V. Conclusion. In this paper, an endeavor has been made to investigate the automatic keyword extraction methods of graph-based approaches. In graph-based approach, top position keywords were extracted by applying the centrality measures on graphs, which symbolize the documents. Because of the centrality measures, the important terms of graphs, which denote the document, is extracted wisely. To sum up, graph-based approaches, for keyword extraction, may yield better results.